notice significant figures. We already talked about the concept of significant figures in the first video. Now we will learn how to identify significant figures and also uncertain digits. Next, we will be working with significant figures. That will be followed by rounding off numbers and then standard form, sometimes called scientific notation. How to recognize significant figures. There are two sets of rules to help you recognize significant figures. The first set is made up with 6 rules. 1. All non-zero digits are significant. For example, 256 meters. You don't have any zeros there, so all of them, each one is significant. So we have 3 significant figures. Now, out of the significant figures, the one on the far right is considered uncertain. So we have 3 significant figures and 6 is the uncertain digit. Rule 2, any zero between non-zero digits is or are significant. 25,006. Now these on the end here are non-zeros. These zeros in the middle there are between non-zeros and therefore they are considered significant. So we have 5 significant figures, 25006, and out of the significant figures, the one on the far right is considered the uncertain digit, so 6 is uncertain. Rule 3, any zero directly to the left of an understood decimal point is or are not significant. Consider the number 34,500 meters. Now we all know that a point is there, but it is not so stated. It is understood to be there. Now these 2 zeros are immediately to the left of an understood decimal point. So they are not considered significant. It means therefore that we have 3 significant figures, and out of the significant figures, the one on the far right is considered uncertain. So 5 is our uncertain. Rule 4, any zero directly to the left of an expressed decimal point is or are significant. Now in Rule 3, it was an understood decimal point. In Rule 4, it's an expressed decimal point. So these 2 zeros here are immediately to the left of an expressed decimal point. Therefore, they are considered significant, and of course these are non-zero digits based on Rule 1. They are also considered significant, so we have 5 significant figures, and out of the significant figures, the one on the far right is considered uncertain. So 5 significant figures, and the zero nearest to the decimal point is the uncertain digit. Rule 5, any zero to the right of a decimal point but to the left of non-zero digits is or are not significant. If you look at a number 0.00342, these 2 zeros are immediately to the right of a decimal point and they are to the left of non-zero digit. Therefore, those 2 zeros are considered not significant. So we have 3 significant figures and the uncertain digit is 2. And finally, for this set of rules, Rule 6, any zero to the right of a decimal point and to the right of non-zero digits are significant. So the number 0.03400 from rule 5 up here, we already found out that that is not significant. But then we look at these two zeros. They are to the right of a decimal point. They are also to the right of non-zero digit. And so we have 4 significant figures, and the uncertain digit is that 0. Okay, this is one set of rules to help you recognize significant. Now, the next set of rules is called the Atlantic-Pacific method. Now, if you look at a map of the Americas, you do have North America up here, North America up there, South America down here, and Central America in between here. If you look carefully at this map, you will notice on the right-hand side, there is the Atlantic Ocean. And on the left-hand side, there is the Pacific Ocean. We can use the position of these two oceans to help us recognize significant figures. It is very easy. As I said, for those who live in the Americas, including the Caribbean, we have the Atlantic on the right, the Pacific on the left. The method has only 2 rules. If the decimal point is present or absent in the number. If you look at the map of the Americas, as we said before, you will notice that the Atlantic Ocean is on the right and the Pacific is on our left. If the decimal point is absent in a number, we begin from the right where you have the Atlantic Ocean. So A for Atlantic, A for absent. If the decimal point is present, we begin from the left where the Pacific is located. So P for Pacific, P for present. We will count every digit as significant once we meet the first non-zero digit. So let's see how we apply this. Let's go back to that number we were dealing with before, 256. In the previous set of rules, the decimal point is absent. You don't see it. I mean, we all understand it is absent. We understand that it is there on the right of the 6, but it is not so expressed. So we will say it is absent. Because it is absent, we will start from the Atlantic side. Go to the left, count every digit we find from the first non-zero digit as significant. So the first non-zero digit is 6, of course. So there are 3 significant figures. We count 6, 5, and 2. We have 3 significant figures. Out of the significant figures, the one on the far right is uncertain. So 6 is uncertain. Let's look at the number 25,006 that we saw before in the previous set of rules. Is the point expressed? Is it present or not? It is not, so it is absent. And so we will begin from the Atlantic side and we will start counting the digits from the Atlantic, which is our right, to the left. We will count every digit once we meet the first non-zero digit, the first non-zero digit. So the first non-zero digit is 6. We count 6, 0, 0, 2, 5. So we have actually 5 significant figures, all of them, 2, 5, 0, 0, 6. Once we have the significant figures, the one on the far right is the uncertain digit. So 6 in this case is our uncertain digit. 34,500, we saw this before. The point is not expressed, so we will say it is absent. We will begin from the Atlantic side. Atlantic, absent. A for Atlantic, A for absent. So 34,500. Point is absent. We will move from the Atlantic to the left. And we will count from the first non-zero digit and everything else on the left. So we will skip 0 and 0 and we will start counting from 5 because 5 is the first non-zero digit that we meet. And so we count 5, 4, and 3. And we have 3 significant figures. And out of the significant figures, the one on the far right is the uncertain digit. So our uncertain digit in the number 34,500 is 5. 3 significant figures. That is if the point is not expressed, it is absent. Now if the point is present, it is expressed as in the number 34,500. Since it's present, we will begin from the Pacific side and count from our Pacific side to the right. We will begin counting every digit from the first non-zero digit, which in this case is 3. So we will count 3, 4, 5, 0, 0. So we have 5 significant figures. And out of the significant figures, the one on the far right is uncertain. So that 0 there is uncertain. Let's look at this number now, 0.00342. We also saw this before when we were using the other set of rules. The point is expressed, it is present, so we'll begin from the Pacific side. Going to our right, we will start from the first non-zero digit, which means that we will skip those 2 zeros. We will begin at 3. We will count 3, 4, and 2. So we have 3 significant figures, 3, 4, and 2. And out of the significant figures, the one on the far right is uncertain. So 2 is uncertain. The next number we want to look at is the same number, the 6th number we looked in the previous set of rules, 0.03400. The point is present, it is expressed. Again, we will begin from the Pacific side. Going to the right, we will start counting from the first non-zero digit, which in this case is 3. So we will count the 3, the 4, and the 2 zeros on the right. So we have 4 significant figures, 3, 4, 0, 0. And out of the significant figures, the one on the far right is uncertain. So this is our uncertain digit. So this is the Atlantic side. We didn't need to use the Atlantic rule here because all of these numbers, the point is present. So we began with the Pacific. Atlantic, Pacific. Once you identify the significant figures, remember the uncertain digit is normally the significant figure on the far right. Uncertain digit has nothing to do with Atlantic-Pacific rule. We need to identify the significant figures first. Once we identify the significant figures, we will then, out of the significant figures, choose the one on the far right as the uncertain digit. So take these numbers here. Whatever rule you are using, 308, we have 3 significant figures. 8 is our uncertain digit. In this number here, 4,600, we have only 2 significant figures. 6 is our uncertain digit. In number 3, 45.000 degrees Celsius. That's very, very precise. And so we have 5 significant figures. This 0 is our uncertain digit. And the number 0.00570, those zeros on the left of 5 are not counted as significant. So those are our significant figures, and this is our uncertain digit. And this number down here, 50.004 milliliters. Now, whatever rule you are using, you will still come up with 5 significant figures. And once we get the significant figures, the one on the far right is uncertain, so 4 is uncertain. And this last number here, 78,945 in kilometers, whatever rule you are using, in this case, I would prefer to use the one that says, if you don't have a 0, all the digits are significant. So we have 5 significant figures, and this 5 on the far right is uncertain. Well, I don't need to tell you that you don't need to learn both set of rules. Choose whichever one you are most comfortable with, or you could use a combination depending on the number under consideration. For example, this number here, I don't need to go to Atlantic Pacific. This number here, I don't need to go to Atlantic Pacific. The first one, 308 meter. This one here, number 4, it's a little more complicated, and I may need to use the Atlantic Pacific rule there. Choose whatever rule or combine them as you like, but once you find the significant figures, out of the significant figures, the number on the far right out of those is the uncertain digit. After we find the significant figures and the uncertain digit, we still have to learn how to add and subtract significant figures and multiply and divide significant figures. So that will be the next thing we will be doing. So in the last video, we talked about the concept of significant figures. In this one, how to identify significant figures and uncertain digit. In the next video, we will learn how to work with significant figures. After that, rounding off of numbers, and then standard form, sometimes called scientific notation. Now, this video here, how to identify significant figures, we have 2 sets of rules. It is not as difficult as you may have originally thought. And that brings us to the end of this second video, identifying significant figures and uncertain digits.